Okay, I believe the screencast is going. I apologize. I recorded a 10-minute screencast. Turns out that the camera wasn't switching to the different platforms I was looking to show you, and so there was sound that didn't match the the picture of what you were seeing. Anyway, this is a great learning experience as well because it teaches me a couple things with technology. It teaches me how to do screencasts. I made my own YouTube channel, and so it goes beyond electricity and magnetism. So thank you for that. The neon discharge tube, I just wanted to show you. I mentioned it, and here it is. And it's just a gas discharge tube. I don't know how useful it is for what we're doing, but I wanted to show you that we do have it, and I guess ask whether or not this would be useful for purposes of electricity and magnetism phenomena. Okay. I also showed you a circuit that I used and made, or that I put together, from a bulb and battery pack and some wires. So I have here a 25,000 microfarad capacitor, battery pack, the bulbs, and one way to show that charge is moving through a circuit. I guess this is not really sort of static charge buildup, which I would love to get at. But what you can show is that the bulb briefly lights, which I had my hand in the way. This capacitor is charged. Then what I can do is show to the kids that there is a static charge buildup on the capacitor. I can then discharge it and show evidence that there was indeed charge buildup on the capacitor, because when I discharge it, it briefly lights the bulb temporarily. So anyway, this is just kind of what I was talking about in the previous video. I'm not going to record, the video again, but I think that you get the feel for what I was sort of discussing there. Another thing I wanted to discuss was diagrams such as these that would be wonderful tools. Really, a model that students could use even for whiteboarding. In order to show the electric fields and the accumulation of surface charge that causes these electric fields. This is similar to multiple representations in any kind of modeling any sort of topic in physics. For example, in mechanics, we have mathematical models, we have verbal models, we have graphical models, and we could also use this in electricity and magnetism. I'm just wondering how much of these diagrams are used in as one of the models for the electricity and magnetism, especially when we're talking about the relationship and the interaction of surface charge buildup and electric field direction and strength in circuits. I thought this was fascinating, and it really kind of made sense to me that the surface charge buildup would then cause the electric field to move in the direction that would correspond to the conventional current, whereas the electric field developed by the capacitor seems to be at odds with the direction of the conventional current flow. And so it really seems to be a necessary sort of mechanism to understand to predict electric fields in the correct directions. One more thing I wanted to say about the showing that there's static charge buildup even in an open circuit. I understand that according to the article, it did say as well that there needs to be very high voltages in order for you to be able to physically measure the electromotive force, I guess, from all that charge buildup on the wires. And we don't have, I guess, those kinds of materials at the school to demonstrate that readily. I'm not sure if we do, I guess, and if I'd be interested in hearing whether or not we can do some demonstrations, and which demonstrations to perform to show students that, there is indeed movement of charge and charge accumulation even when there is not a closed circuit. A few other things about the paper that we read by Sherwood and Shabay. One is that it really seemed to, and then as is the case for the modeling curriculum in general, it seems for any physics topic, there's really a development of qualitative understanding and qualitative sort of concepts, understanding them qualitatively before we get into the math so much, which is wonderful. My physics experience in the past in college was more of a quantitative equation first type of method, which, you know, traditionally has been done for the most part. But this paper, as the course, I believe, will proceed to develop a qualitative understanding before we go ahead and do the quantitative understanding. But it does say in the paper that there are the equations that we can use to predict electric field strength, to predict charge within circuits. And so that would be fascinating if we can get into some of that, because it took me a little while in order to go through those equations that were described in the paper to understand, you know, some of those terms, even some of those variables in the equations. And, you know, I haven't yet tried to go and figure out some problems quantitatively, but it would be a wonderful experience to do so. I'm not sure if the modeling curriculum, the materials would go into that type of sort of complex calculations, but that would be wonderful if I could maybe look into more resources by these authors to see if I could go ahead and find some problems to try. Another thing, I've taken some notes on the reading. And one more thing, last thing I guess I'll say about the reading is that electricity and magnetism seems to be a bit like chemistry. You can't really see what's going on, and you need to consider things on a microscopic level to really understand and relate to the phenomena that's being described. And that's the kind of, I guess, thinker I am. I really would like to understand at a mechanistic level what's causing for certain things to happen. And so it seems to be a much richer experience to go through this sort of microscopic analysis of circuits in this course in order to both gain a bit deeper understanding for myself, but also to engage students so that they are able to relate previous physics concepts to electricity and magnetism and just use those again to analyze circuits. These things would include vector summation, net forces, and so on. The pretest that we took the first week, February 3rd, it sort of threw me when I initially saw it. I have not thought about electricity and magnetism so much since last spring. And also the paper was, really challenging, I guess, mentally for me. But working through it and doing a little bit of extra legwork to go ahead and look up some equations, maybe look up some variables and what they mean in the paper really helped me. And I feel confident, that this material can be learned better. And also the pretest that we did, I went back and I just remembered some of the concepts that were gone through. And I know we can probably find this on the materials or on the internet, to get permission to see this test. And I'm not doing that because I want the course to kind of be the teacher to see if, I really will gain in the post-test. But anyway, I did go back and look and do some research on some concepts that I remembered from the pretest. And these are things even as simple as Coulomb's law, some of the other current flow ideas, series versus parallel circuits, voltage difference in electric field, looking at the difference between electric potential and potential difference. These ideas are not easy. And so I look forward to